Hi, my name is Martin Freegard, and I'm going to talk about efficient testing for your Shiny application today. A little bit about me. I'm a data visualization engineer. I work for Attendees in Shiny application development. And I like working on identifying those tests that matter in terms of the key features for an application and in terms of the business value that they bring. Today, what we're going to focus on are three different portions of testing a Shiny application. The first is just going to be the flavor of tests that we have available to us: unit tests, integration tests, and system tests. I'm going to talk a little bit about the test suite that you can build in your Shiny application, assuming it's in a package. The development portion is going to cover the differences a little bit between standard application development and what is called behavior-driven development. I'm going to talk about how you can use conversations with stakeholders and users to outline features and scenarios that really give you a better idea of what to test. And then I'm going to jump over to efficiency, where we'll talk about what you should test, how you should test it, and really how you should think about code coverage. Okay, so let's jump into Shiny testing. So testing your Shiny application is much easier if your application is in an R package. It's not impossible to test a Shiny app that's not in our package. It is just less desirable. Shiny applications stored in R packages do require functions and packages beyond just testthat. They also benefit from having a kind of well thought out test suite, which includes things like the fixtures we're going to discuss and the helpers. And it's really important during your application development and testing process that you keep a close eye on the R files in your R folder and the test files in your test folder. The naming really matters, and you really, in an ideal situation, you would have a one-to-one relationship between the functions, the R files in the R folder, excuse me, and the test files in the test folder. Okay, unit tests. So unit tests are handled by testthat. This is kind of a standard R package feature. They focus on testing a specific unit of work and verified it against an observable result. An example would be any function in which you are passing an input, a vector, a data frame, and you have a known output that you want to verify it against in an expectation from testthat. So, like I said, these are pretty standard for our package development. Unit tests are a really important part of your business logic with your Shiny application. So if there are any utility functions that are included, you want to make sure to include those with your basic unit tests. Excuse me. Integration tests, depending on who you talk to, integration tests can be Shiny test2 tests or test server tests. I tend to think of these as a test server test because test server is a great Shiny function that actually allows us to pass in either, if your application is in a single app.r file, you can pass the server to it or a full app itself, or you can pass a module server function to the app argument of test server. And it can handle the reactivity, which is nice because you can look at the returned values, you can check inputs and outputs. But because this almost inherently requires that even though you're passing it a single function, modules almost never exist in isolation. They're either calling other utility functions or their Shiny functions. So to me, that kind of indicates it's an integration of components within your application. A lot of times the clearest example of a test server integration test is you want to make sure that the modules in your application are communicating as expected. So if you have a module that's returning a set of values and then being passed kind of downstream to another module that's maybe generating a table or a graph, this is a perfect example of an integration test with test server. A system test is performed with obviously Shiny and Shiny test2, previously Shiny test. Shiny test2 is really more of an end-to-end test package. What it's going to do is it's going to create an app driver, which allows you to develop tests that give you the ability to basically step through a user experience with your application. So this is where you get exposed also to the test recorder, which is a GUI specially designed to allow you to interact with your application and then record those steps into a script or a snapshot that you can later test against. So Shiny Test 2 tests do require a little bit more time to run. They're just a little bit, obviously a lot more going on. They tend to happen kind of toward the end of development. So this is kind of after your unit tests have been developed for any utility functions or business logic. You write some modules, you develop some integration tests to make sure they communicate effectively, and then you do kind of a user experience Shiny Test 2 system test just to make sure everything's working correctly. So in addition to these three types of tests, we have test fixtures, which is part of your test suite. A test fixture is really anything that will generate a repeatable test condition. It can be functions, data, really anything. Kind of my rule of thumb for the test fixture is if you have any function or process that takes a significant amount of time to execute, then it's probably better stored as data and loaded into your test. Alternative data sets in your application would be one of these cases. Rather than trying to do a bunch of data manipulation in your test, you would just store the manipulated data file in fixtures and then load it into your test. So a couple things about fixtures. A good fixture will provide a consistent, well-defined test environment. Part of that is removing or destroying itself after the test is executed, so nothing is left to interfere with any other tests. And we want to make sure that any artifacts that we have or any test code that we have above testthat, we do our best to remove, because we want to keep our test clean and really have everything operate on that test within the testthat function. So as an example, I have a ggplot custom function that I'm using in my application. It's been written to handle the string variables that are going to come in from my input IDs. So Erlang provides this data masking where I can assume that the X variable is going to be a character string, and it's just going to pass that directly to be interpreted by the ggplot2 function. It's essentially doing the exact same thing as your ggplot template would. It's just allowing for those input $X, input $Y values that come through. So using a test fixture, the place to store them is actually under tests and testthat. Fixtures is not a required name. It's descriptive, so probably recommended, but you can name that folder anything. Here you can see when I'm creating a test fixture, I'm storing the code that was used to generate the fixture right next to the actual object itself with some obvious naming convention like make object. This particular script takes the ggplot2 movies data and makes it long or tidy. There is a justification, as we'll see down the road, if you find yourself using test fixture data, especially if you have test data that you're using in more than one test. It does beg the question why this isn't just included as part of your package data, meaning move the script into data raw, have that saved into the data folder, and just make it part of your package namespace. That's really up to your own discretion, but it would definitely make a lot of the work easier for you in future tests and also for other users of your package. If you're loading a test data, a static test fixture, testthat has this handy test path function. It works a lot like system path. So you pass the folder name and then your name of the data file. And you can see that I can load this directly into my testthat chunk. I'm then using that particular test object with my custom scatterplot function, and I'm just verifying with an expectation that it is actually generating a ggplot2 graph object. As I mentioned, if your test fixture is used in a variety of tests, or it is used in other places, like if it's used in examples, sometimes it's worthwhile to just include it in your package data. Another thing, this isn't directly related to the fixture, but it is important for testing. In this particular case, I just want to verify that this object from scatterplot is a ggplot2 graph. In this particular instance, I don't want to create a snapshot because I don't need to visually inspect the contents. I can do that with the examples, or I can do that right in the console. But what I do want to verify is that when I pass it a combination of strings and values, that it still generates a ggplot object without any errors. Because my assumption is this function is going to be used in a Shiny module with render plot and plot output. And so I want them to be able to kind of handle, testing whether or not the output looks right. Shiny is going to do all the testing for the render function, so I don't need to worry too much about, the UI output and that kind of stuff. I can just test my utility function, verify that it's creating the correct object, and then if I want to include a snapshot to show to a stakeholder, I can do that. But this, in my opinion, works fine in terms of I feel confident this will generate a plot output in my display module or in render plot and plot output. Okay, test helpers. Test helpers are really designed to help reduce any repeated or duplicated code, especially any code that lives above your testthat call. If an object isn't quite large enough to justify being stored as a static test fixture, it could definitely be generated with a helper function. For example, if I want, let me include, you store you store helpers in testthat helper.r. This can kind of collect a variety of functions, and it'll automatically be there. When your tests are run, when you use DevTools test or test active file, those functions will be available. So in the previous example, I had a set of inputs that were passed to my scatterplot function. I could store these as an object and then put them in fixtures, but as you can see, it's a pretty small list. There aren't many values. So this might make sense to store it as a helper and just write a function that generates a list of inputs. You can see why this might be beneficial, because when I refer to the object in the module that it is being called in, it will actually use the same syntax, right? So I can actually refer to, var inputs in this test actually looks a lot like the reactive syntax that I would use in the module. Unfortunately, for future me and anyone else who looks at this test, it's not really clear what is in var inputs or where it comes from, without digging through my helper file or just remembering that, oh, that's not var inputs the module, that's var inputs the function that generates those values. So before you generate, this just is highlighting the area that is identical to what you would see if you were calling a reactive var inputs object. When you're considering whether or not to turn a set of values or anything into a helper, the two things that I ask myself is, does the current code explain what the behavior is that's being tested? And would the helper make it harder to debug or easier to debug when the test inevitably fails? And I think that that's one of the driving points that really helped me consider whether or not to develop a test helper, is that if it's making it easier for me when they pass, it's probably not helping when they fail. So a lot of times the test code and the test file really needs to be written under the assumption that it will be in the debug, it'll be debugged by someone who's not writing it today, and probably when it's failing, and probably under a deadline. So you want to try to have it be as explicit as possible. I think that Clarity really trumps brevity when it comes to writing your tests and your test code. So I can still create a helper function though, because if I just decide I don't want to have a function that I'm calling the same way I would in a module, I can still use glue to generate the list that I'm going to be passing, maybe a variety of times into my tests. And what's great about a make inputs or make ggplot2 inputs function is that it reduces the keystrokes and neurons, right? I don't have to manually create the list every time. I can just pass my helper function into the console, copy that list, drop it in there, and it maintains the expressiveness or the clarity of what's being tested and what's being passed into the test itself. So I use glue quite a bit when I'm trying to just quickly generate code that I know I'm going to use repetitively. Okay, so we have covered types of tests and some components you can add to your testing suite to make testing a little bit easier. The next portion of this talk is going to really dive into behavior-driven development and how it can help you develop better tests and how it can really help guide the development process. So, traditional development really focuses on coding and applications functionality. The user specifications sometimes will actually go beyond what they need and actually include a solution. And this isn't necessarily their fault. Sometimes they're trained to actually write up specifications, with the proposed solution. But what that does is it sort of binds the developer to a particular implementation, or it kind of confines their thinking in the technical implementation of that specification instead of just finding an optimal solution. This is just part of writing up software requirements specifications and just kind of the language that's included in those documents. Sometimes this can lead to a delay in test development because you're trying to figure out how to develop the technical implementation that was proposed in your solution, and it might not fit with your mental model of how the application should be designed. So testing usually is the thing that gets the short end of the stick because it's almost always done at the end of a project lifecycle. So behavior-driven development it's a process geared toward meeting desired behaviors and collaboration between user stakeholders and developers to collectively come up with a set of features and scenarios that can help guide both development and testing. So it starts with a really solid understanding of the user needs. This is done through a variety of meetings and discussions. Feature mapping is a common exercise used to help really outline what exactly the key features of the application are going to be, and then what business value those are attached to. So a great thing about this that I like is that it acknowledges that the specifications and requirements, they just change and evolve over time throughout the software lifecycle. And it's not to say that the original specifications or requirements are wrong. It's just that things change, and sometimes the value that we thought a particular metric was going to have maybe doesn't have that value anymore, or we thought of a better way to derive that value. So by acknowledging that these specifications and requirements will change and evolve, we can instead focus on features that deliver value, and we can use scenarios to really guide how we're going to test and build these features. All right, how does it work? It's a lot of teamwork. It really requires a lot of conversations and discussions to improve the understanding of the application functionality by uncovering any hidden assumptions, either by the user, the stakeholder, or the developer. Considering potential risks that one party maybe had not considered, and really building this shared appreciation for both meeting the user needs and achieving the business value. This is something that when you kind of have all parties buying in, you can really develop well-written features and scenarios that describe exactly what it is the application is intended to do and the value it's intended to bring. So, what is a feature? Features are the tangible functionalities that get you to where you want to go in terms of your business goal. When describing these, it's always a who wants it, what is it doing, and what is the value. This is an example syntax, or example Gherkin syntax. Gherkin is a behavior-driven development language that's used specifically for mapping out features and scenarios. The feature syntax is as a whatever your role is, I want, and in order to, the value is really in that final statement. These can be restructured. You can start with the value statement, to achieve some goal as a whatever your role is, and then whatever action to perform. I think that because this is a really user-centric process, it's nice to start off with the as a user or stakeholder, because it kind of drives home that point of the person that's going to be sitting at the wheel when they're operating this application. So, describing features. When we're describing features, we want to use a first-person voice. We want to state what the user needs, and we want to state why they need it. So this is an example of a feature for an imaginary C-disk variable exploration dashboard. And so as a researcher or analyst, I want to be able to explore the variables in the vital signs analysis data set so that I can analyze and drive insights from the vital signs data. So you notice the language is very non-technical. It's meant to be read by anybody who just came across the application or the test scripts. It shouldn't require any kind of specific knowledge. Acronyms are spelled out. Unfortunately, I didn't spell out C-disk, but the goal with this is really plain language and clarity. Scenarios are what we derive from the features. So scenarios have 3 keywords. They start with a given, and this establishes the preconditions or the initial conditions for the scenario. It then has a when keyword, which specifies that action of whatever's being tested. And the then is the outcome that we're expecting from the action. So in the Gherkin syntax, a scenario has a concrete example of a given initial condition, an action that's going to be tested, and an outcome that we can expect. So when you're writing scenarios, the way I like to think about it is you set the stage, right? Here's a feature for a user login. What I'm outlining here is a successful login with the correct credentials, and given that the login page is loaded, so the user is sitting at the application, the dialogue is there for them to provide their username and password. I then add the action and the outcome. So when the user enters a valid username and password, what happens next? And then if there is anything beyond the initial then, you can use an and statement, or if there's a redirection, you can use a but statement, right? So given, when, then, and but is totally fine when you're outlining the steps in your scenario. We can, like I said, we can layer on more outcomes kind of as needed. We can also describe an alternate scenario right under the same feature. So this feature outlines a successful login, and this feature outlines an unsuccessful login, right? So in our in our feature description, we're going to have a single feature listed in the scenarios in which we'd like to test. And what this does is it gives us a really clear understanding of what needs to be included in our test files. And what else is nice is it, in plain language, describes what's going to go in that testthat expectation, tells you what needs to be built as the developer. It tells you what kind of data needs to be included. If there's a helper that you want to write, this is a great way to kind of preview what that might be. Efficient testing really does mean writing those scenarios, or at least thinking about those critical paths for that key feature. Because at the end of the day, when time is limited, you want to make sure that those key features have tests and that those critical paths have scenarios that have been thought through for the user. So obviously, ideally, everything is tested, but in reality, we have to make sometimes decisions because of timelines and just resources, what to test. If you've followed some of these behavior development testing processes, you'll have a better idea of the key features and expected behaviors. Then you can prioritize those scenarios and really test what is essential to the business value first. And then you can just kind of adopt this inspect and adapt posture. A lot of this is just going to be continual iteration. Like I said, this acknowledges that the requirements and specifications will change over time. So, there's a lot of benefit in just making sure that you prioritize those, that you can identify what those key features are, that you've written those scenarios or at least talked through them, and that you have a test suite that addresses what the user primarily cares about and what the business value, really, what is the highest business value. So the good news is testthat does have support for BDD. It has two functions, describe and it. And these I like to use for features and scenarios. And so, for example, the test that we ran earlier, one way to do this, obviously there are many ways to kind of use these in combination, but I like to include a feature in the describe block. And what I'll do is on a multi-line text string, I'll just go ahead and include the feature description. So as a, whatever the role is, I want whatever, the desired outcome is, and then the value proposition so that whatever the outcome is. This is nice because I can include all the Gherkin syntax, see it clearly, and then in the code portion of the describe function, you can drop an it call, and these function just like a testthat. So it's an isolated test environment. And so in here, in this block, I will outline a scenario. So now I have feature and scenario, and they're easy to read. They're in the test file itself. So I don't have to, just wonder what scatterplot works means. I can actually look at the feature in the scenario, and then the test code is included right beneath it. It's also great to refer back when you're developing the test, because a lot of times by looking at the feature and scenario, you'll remind yourself what it is that you are actually testing and what they actually care about. I highly recommend if you're testing a Shiny application that's in an R package to at least look at using these BDD functions, because they really give you more context to outline some of those application features and execution paths that are a little bit difficult to capture in a single call to testthat. So one of the things that is so neat about describe is that you can actually nest multiple describe calls. So if I wanted to, I could have, the feature, the scenario, and then if I wanted to include maybe just the then statement in a call to testthat. Maybe I want to describe feature, describe scenario, include the given and when, and then in my actual testthat include then. That is totally fine because you can nest these. Like I said, it's great if you like thinking about tests this way. Also, I found it's just really helpful for kind of organizing the way I'm thinking about my integration tests versus my system tests. Next, we are going to discuss what to test. So in terms of efficiency, I have to say there's nothing to report in terms of unit tests. There's no way around the fact that all of your business logic should have a unit test. If it's generating a model output value, something that's being used in your whatever your domain is, I think you would agree that does need to have a unit test. It's important that all functions that are being used in production are tested. I think the integration tests, if you are under a tight timeline, the important thing for integration is really the handshakes between those different components. So a lot of times I will write the tests that basically connect my maybe variable input module, to my data display module, or some user input to some kind of graph or table output. I'll make sure that the connections between the modules have tests, and that those tests are run every time I either push it to GitHub, or I run DevTools test or DevTools check, just to ensure that the modules are communicating with each other effectively. It's not to say that's not all you would want to do with test server, but that does at least handle, like I said, the connections or the handshakes between those modules. System and end-to-end tests. The thing that's really kind of off the table immediately when you have a tight timeline and you're concerned about efficiency are edge cases and non-critical execution paths. So I like to think of this as if you were submitting an application for a loan, it's whatever gets you to actually be approved is that primary execution path, because that's the primary feature, the key feature. That's the business value. All the other ways in which you could not be approved are non-essential. So we really want to nail that down first, and then edge cases, really just as you have time, you address edge cases, or if bugs appear, obviously you want to make sure to handle those. Those shoot at the priority list as soon as the defect is shown, or you identify a bug. Test coverage, the title of the talk. So the reason that I think test coverage is a little bit of a dubious metric is just that it assumes all execution paths are equal in your application, and every time someone's developing an application, the goal of making it dynamic is to provide a user with options. But there's a primary execution path that most of the time we're envisioning the user having, and so that really needs to be obviously that's probably the one with the highest value, and that really needs to be the one that we care about the most. So test coverage, as much as we care that it's exhaustive, we do care that the functions have all of the execution paths covered. I think that in terms of prioritizing them, test coverage just gives you the percentage. So if there was a way to identify those and then focus on those, I would start there. And that's really where I think something more like a traceability matrix, where you can actually identify specific functionalities and match them to the tests that check them. I think that's a little bit better for both a communication tool between you and users and stakeholders, and with the development team, right? You can have a traceability matrix that maps out those primary, those key features, and make sure that the tests are written for those. And then as you kind of progress throughout the life cycle of the project, as long as those tests are passing, you can continue to add functionality and list the tests in that matrix. One final point to remember. Today's functionality is tomorrow's regression. I really enjoy this quote because it's just a reminder that every new feature we're adding today is going to be a regression test in the future. It's going to be the thing that we're seeing, I don't want to say degrade, but it's going to be the thing that we're hoping stays stable over time. So it's important that you just maintain kind of the idea that your application will need continuous testing and development every time you're adding a new feature. And the goal is to make sure that all new features don't interfere with or break the existing functionality. And that's really where I think those conversations from behavior-driven development really come into play, because if you're working on a project in coding, I think it's easier to forget all the lines of code that you've written, but it's harder to forget a conversation with a colleague or another stakeholder. I think those tend to stay in our memory a bit longer, and it helps you recall the work that you've done and really what you should be expecting in terms of features and outputs. So Thank you very much for listening, and be sure to check out my full workshop at RN Pharma, developing and testing Shiny applications. Thank you.